boy Logan purchased a used pickup truck. He should get 20 miles per gallon, and the recent price of gasoline was about $2.50 per gallon. So first step, create a table of values that tracks the amount of gasoline required to drive a given distance. All right. So if we're going to go 100 miles, you get 20 miles per gallon. That would take 5 gallons because 5 times 20 equals 100, right? So 150 is 7.5. 200 would be 10. 250 would be 12.5. 300 would be 15, and 350 would be 17.5. So that's how much gallon we would use. So what is our function rule if this were going to be f of x? F of x, where x is the number of miles, we know that it's going to be equal to, it is 5 over 100 times x, which is equal to 1 over 20 times x. Or let's go ahead and use decimals. F of x equals 0.05 times x. So if I were only going to drive 1 mile, I would need 0.05 gallons, 1/20th of a gallon. All right? Now, second step. Let's create a table of values to talk about the cost of the gasoline purchased. And we're going to use these same values that we generated up here. So 5, 10, 7.5, 12.5, 15, and 17.5. All right? So we know that our gas was $2.50 per gallon. So $2.50 times 5 is $12.50. So that's $12.50. All right. And then times 7.5 is going to be, we're going to add $6.25 to that. So $18.75. And then times 10, well, that's going to be $25. And then $12.50, this is going to be $31.25. 15 is going to be $37.50. And 17.5 is going to be $43.75. That's at $2.50 per gallon. All right. So the function g of x then, g of x is equal to 2.50 times x. All right, because it's $2.50 for every gallon, where x is the amount of gallons. Okay. Now, looking at these two functions, so the output, which is the range for f of x, how does that compare to the input or domain for g of x? Well, the output for f of x is the amount of gallons of gasoline used, and that's the same as the input. All right, so we can say that the range of f of x is equal to the domain of g of x. All right. So replace x, the input of g of x, with expression that describes the output of x. I write the function g of f of x. We read this as g of f of x. All right. So what we've got, we know that we want to have g of x. We know that g of x is 2.50 times x. But what we're going to do instead of x, we're going to write f of x. So we're going to write g of f of x. All right, so everywhere that we saw an x in our function rule, we're going to instead write f of x. So 250 times f of x. All right, but what is f of x? F of x is equal to 0.05 x. So that means we can change this. We can say that g of f of x is equal to 2.50 times 0.05 times x, because f of x is that part right there. Okay? So that is our eventual rule, and you know what? We can simplify this one step further, and I'm going to write this down here. G of f of x, and if we do 2.5 times 0.05, let's look at our calculator. C-A-L. We're going to do 2.5 times 0.05, and that gives us 0.125. So that is our eventual, oh my stars and garters, are you kidding me? Wow, that stinks. So let's see. What did we get here? All right. So going back, sorry, we had g of f of x is equal to 0.125 times x. All right. So we are calling that h of x in this case is equal to this rule. So we would say 0.125 times 100, well, that's going to be equal to 1250. All right. And then we would say 0.125 times 150, which is 18.75. And then we would say 0.125 times 200, which is going to be $25. And 0.125 times 250, which is going to be 31.25. And then 0.125 times 300 equals 37.50. And 0.125 times 350 is equal to 43.75. All right. So what is the function h of x? Well, as we just revealed before, h of x equals 0.125 times x, and this is the same. So what we did, and I know it's been deleted from record, we started with the distance in miles. This was 5, 7.5, 10, 12.5, 15, 17.5. We put those amounts in here, 5, 7.5, 10, 12.5, 15, and 17.5. Got the cost of dollars and realized that they were the same however we did it. So whether we went step by step or used the function rule. What we have just created is called a composition of functions. That's when you do one function, you get a result, you get an output, and then you take that output and you put it in to the next function. That's a composition of functions. You might see it written as g of f of x. And again, so we say it like that, g of f of x. Sometimes we use an open circle. So we do g of f of x. And sometimes there's a parentheses around it. Sometimes there's not. So it might look either one of those kind of ways. Excuse me. All right, so let's practice on a few just mathematical examples. So here we have g of x and we have f of x. What is g of f of x? Well, let's see. If g of x is 5x, well, g of f of x is 5 times f of x, which is 5 times, and the rule for f of x is 3x minus 2. So g of f of x is 15x minus 10. All right. Next one. G of f of x equals 2f of x plus 3. So that's going to be 2 times, and then we put an f of x here, 4x minus 5 plus 3. So we distribute the 2. That gives me 8x minus 10, and then I do plus 3. So I've got 8x minus 7. Boom. Next one. G of f of x equals 2 times f of x minus 5. Well, f of x this is going to be 2 times 3x squared. That's f of x right there, minus 5. So this is just 6x squared minus 5. And then our last one, and again, pause on all these if you want to. We're going to do g of f of x. That's going to be equal to 3 times f of x squared plus 2 times f of x minus 3. All right, so we got to plug f of x in twice in this case. So that's 3 times f of x is just 5x. So 5x squared plus 2 times 5x minus 3. So remember, PEMDAS means we have to square this first. So this is 3 times 25x squared plus 10x minus 3, which is equal to 75x squared plus 10x minus 3. That is the last g of f of x. All right. Hope you have a great day today. I'm sorry I missed it if I'm not here for you. And be nice to the sub, and we'll see you next time.